there were several improvements in how the sequence diagram looks like. So some styling improvements to make the diagrams look more compact, and there are new tooltips. So let's try to run this application. Yes, first we start a web view for this traffic light web. And now we need to run the application with the tracing turned on. So we need to go to the folder with the generated code and this traffic light web target. Yes, and we open default in a terminal. And now let's just, so the web UI is running. Let's start the application. It's called TL system. Yes, and by default, we select the tracing with -URTS debug equals, and then in quotes, trace on, and then quit. Yes, and let's just first start it like this. And we can also see what is now happening in the UI. Yes, so we see that the traffic light is going. We can click this button once pedestrians wants to cross. Yes, now there is a timer, and now the traffic light is running again. So now we can stop this application and see the trace file that was produced. So let's first open the sequence diagram and see how the sequence diagram would look like for this trace file. So we can observe that now it is more compact, and also if you hover over to the messages, then we see there are tooltips for the message and its event and its parameters. Also on the right, we can see there is a new external lifeline. This is a new lifeline representing events which don't have a sender. Normally, those are the events that are injected into the application by some external, from the external port. In this case, this is a TCP event that comes to the TCP port, and it is injected by the TCP server. So also another improvement is that now it's possible to navigate from the trace, from the sequence diagram to the trace file. So now we have clicked to this event, right? And we have navigated to the trace. So here we are now on line 33, right? So we have navigated from this RT bound event. If we see on line 33, we can see that also the port information is now traced. So we see that the server and the port is traffic light, and a traffic light instance, and the port is server. So it is also possible to navigate further. For example, if we click on one of these ports, control click, we are navigating to the module element where the port is defined. And also, if we go back to the trace, if we want to know the information about the instance itself, for example, this traffic light, then we click on the instance, yes, and then from this instance definition, we can navigate to the definition of the part or definition of the capsule. For example, this server, yes, and as well definition of the capsule. But this has been working before in the same way. Now there is a new possibility to see ports in the trace and navigate to the ports. And one more big improvement is that now we support trace configuration, and we support tracing for the timestamps. So for each trace which is generated, on top you can see in the comment this a JSON object describing trace configuration that was used for this particular trace. It is commented out, but it's possible to copy it to any other place, any other editor, and uncomment and parse. This is a JSON information in JSON format. Also, if we see on line 17, there is an additional object trace which holds information about the trace itself. This is not related to the configuration, but this is an additional information also included into this object. Currently, we see that start time is printed here. So, and for the timestamps, we have the mode, which is relative or absolute. We can select precision and also one of 3 timestamps that we want to trace. Matthias, do you have the picture about the timestamps somewhere?
I have it somewhere here. I think it is.
Here, yes. So this is a picture that describes what these timestamps mean. So T1 is the time when the sender places a message into the queue. Then T2, we call it the receive time, when the receiver's controller delivers a message to the receiver. And also we have T3, handle time, is the time when the message has been processed, meaning that the transition in the state machine that handles the message has been completed. Currently, we support tracing for T2 and T3. T1 is not yet supported. So let's try to create a configuration file and configure the timestamps. So normally it's good to create it in the project. We select new file, and then there is a new command, new trace configuration. By default, the name is trace config. But also you can use any name which ends with .traceconfig.json. So now we have created a file called traceconfig.json.
I think I placed it wrong. I should usually put it here, right, in the source code.
Yes, it's better to put it to the project, to the original project. So this is the default name of the file. Also, it's possible to create another name, but it must have an extension .trace-config.json. So here we have an additional schema that allows you to generate proper JSON. There are tooltips that show what are the possible options for the fields. And also, if we hover over to the name of the field, we see a comment what the field means. And if you also can check what the time values mean, we hover over and we can see what it means. So there is another option, precision, that is the granularity in which elements we want to get the timestamp. So it could be nano, micro, or milliseconds, and by default, we select nano. So this is the default information. And by default, all 3 timestamps are turned on. So let's turn on the second and the third one. And also, it is possible to add custom information to this configuration. So if we add one more property, like some custom my data and any value, if you need any comments related to the current trace, then you can also put it here. So we now let's save the trace configuration file and run the application again with the tracing turned on. So there is a new option, -trace config equals, and now if we are using a full path to this file. So if you make a mistake, now if we do a mistake like JSON1 in this name and run the tracing, then it will stop immediately, saying that the trace configuration file cannot be opened. So now let's run it with a proper name, and we can wait a little bit, do some similar actions here. Yes, now the traffic light is going again, and maybe we can stop. So let's observe what is the content of the trace file. First of all, you see the trace configuration, it holds the custom data. Also, it holds the documentation. That's an implicit field, again, saying about what the fields mean. And we have selected these two properties for the timestamps, and they are true. And at the end of each message line, we see a JSON object that holds information about time 2 and time 3. And as Matthias has shown, this information can be used further by the scripts to analyze the performance of the application, of the execution. This tracing solution is available in code real-time as well as in model real-time. Since this is provided by the target RTS runtime library, which is the same for both products. So in model real-time, it's also possible to get a similar trace and then visualize it using a sequence diagram editor in code real-time. The only difference is that if you open it in the code real-time, then navigation will not be possible since the original model is in a different product. But all the visualization and the scripting will be working.
You mean the opposite? If you have it in code real-time, navigation works, but if you have the model in model real-time, you cannot navigate from this trace file.
Yes, I mean, if you generate a trace in model real-time, then you open it in code real-time, then the navigation to the model will not be working.
Yes.
But all other visualization and analysis will be available. So you can play with this trace by specifying a different precision. It's also possible to see the tracing in absolute or relative timestamps. And the start time will also respect the precision setting, and it is also generating the timestamp with the selected precision. But it's also always an absolute time, which the format can be parsed by generic functions that work with the timestamps and time syntax.